This submission focuses on using automated and correlated data views for dynamic analysis of large datasets. We have developed a visual analytic tool which takes advantage of GPU computing and multiple displays. It enables us to interactively analyze and visualize large datasets, such as the AVIST 2012 challenge datasets with 23 million records. Our tool, which is called AVIST, includes multiple coordinated views, such as histogram view, parallel coordinates view, and dynamic view. These views are controlled and synchronized by the AVIST control panel. AVIST has three unique features. The first is automated animation. In Animation Control Panel, the users can drag the timeline bar and the time range bar to change the data views according to different time window. The panel also has an auto animation button to automatically forward the time to see the dynamic changes of all the data views. The second feature is the support of interactive editing of complex highlight and exclusive filters for all the data views. By using 6 different editing modes as controlled by toolbars, the user can create any disjunctive normal forms as filters. The first 3 editing buttons on the toolbar, which is colored red, represent exclusive and all highlight selections. And the last 3, which is colored blue, are for exclusion selections. We can see that we are creating a disjunctive form of filter with 5 conjunctive clauses for highlight selection. Now we're creating an exclusion filter with 4 disjunctive clauses. The third unique feature of AVIST is the support of visualizing multiple datasets together with synchronized time. In this example, we show both firewall log dataset and IDS log dataset side by side. We can play auto animation, drag the time scroll bar, and create different filters for each dataset. With time sync control, we are able to identify the similarity of the temporal patterns between different datasets. The first thread we find from the datasets is some kind of a port scan using source port 80 on the destination ports. We can see dynamically from here, and they're using a set of source IP address which belong to websites, and the destination IP addresses are the unknown IP addresses not listed in the architecture. And also the time is start early during this time and for 2.5 hours about, and they're gone. Then they start this whole thing again. If we identify this, the length of these 2 scans are identical, about 2.5 hours, and the first one start around here, which is late in the about 6 o'clock in the afternoon, and the second one start also about 6 o'clock in the afternoon, so it's actually 24-hour difference. The second issue we find out is actually the RRC port activities through here. By play the motion, we can see through sometimes these activities start coming from a small set of source IP addresses accessing one of the destination IP address, which is the firewall. Although all this activity is being denied, we can see from here, but it's very strange why those IP addresses, which are the websites, they provide website service, they're using RRC to access this by scanning using all kinds of random destination port. Actually, we can see through any time this happens through the time. but through a big range we can basically tell, by increasing the range we can pretty much tell all the destination ports pretty much being randomly used to scan. The third thing we find out is the destination port RSA activity. We can find out some kind of source port scanning happens from a set of workstation source IP to the website's IP that's using the RC port as the destination ports. You can see all this kind of a source port scanning activity happens, and in the beginning only a small set of the source IP address being used, and then more and more IP being used. Looks like they're more being infested.